All right, here we go. This is our Trig final exam review. We are in chapter 3. This had everything to do with the unit circle. So if you don't have one, go ahead and get out a unit circle. Here's one. I'm going to be flipping back and forth to this thing quite a bit here. So just kind of to recap, I have our degrees are in black, the radians are in red. The order pairs, they go cosine, sine, right? The cosine is associated with the x value, sine is associated with the y value. I got those in green and blue. And then the tangents are going to be kind of on the outside, the ones in orange. So if you don't have it memorized, I personally don't have it memorized. I only have a first quadrant memorized, and then everything else is just kind of a reflection of that. But we're just going to be flipping back and forth on this. So use the unit circle to evaluate each expression. All right, so the first one, tangent. So if we just think about the tangent of 7 pi over 4, find 7 pi over 4 on your unit circle. Here it is. They want to know the tangent value of that one. Well, it's just -1 here. So the tangent of 7 pi over 4 is equal to -1. All right. Now, this next one, cosine of -315. -315 is not on our unit circle. So what we need to do is we need to find a coterminal angle. We talked about this in the last video. A coterminal has the same ending spot. So if I were to draw a graph up top, if I were to draw some angle in standard position, looks like this. All right, we could think of this as two angles. We have one over here, which is at, maybe that's 120 degrees. All right, a coterminal angle would end at the same spot, maybe going the other direction, or maybe it goes around twice and ends at the same spot. Those are all coterminal. So to find the coterminal of -315, you add 360 to it, right? That's how we find coterminals. Just add or subtract 360 until we get something between 0 and 360 degrees. So a long-winded explanation, just add a 360 to it. So what is that going to give us? That is just 45. All right, so really we need to find the cosine of 45 degrees on our unit circle. And again, if you have that one memorized, great. If not, find 45 degrees. Cosine is the x value on this one, so that is the square root of 2 over 2. Right. Similarly, this one is a negative pi over 6. So negative pi over 6, you need to add a 2 pi, because 2 pi is the same thing as 360. Throw that up top here. 360 degrees is equal to 2 pi radians. There are multiple ways to measure degrees. There are multiple ways to measure angles. The one that we focus on, growing up is degrees, but radians end up being a little bit more efficient. Right, so to find the coterminal angle here in radians, make sure you are comfortable with your fractions. We need to get a common denominator here, so I'm going to multiply the top and the bottom by a 6, so I can match those denominators. So we're going to go a 6 on top, a 6 on bottom. All right, so we're going to have this whole thing turns into 12 pi over 6. So -11 pi over 6 plus 12 pi over 6, that gives us 11 pi over 6, which is definitely on our unit circle. So sine of 11 pi over 6 is right here. So that's -1/2. Right? The secant of 135. This is 1 over the cosine of 135. All right, so if you want to think about this, this is 1 over, let's find the cosine of 135. So here's 135. Cosine is negative square root of 2 over 2. All right, so if we fix that, we're going to call this -2 over the square root of 2, and then, of course, rationalize it. So our final answer here is going to be, well, let's see, negative square root of 2. let you guys rationalize that one. Cosecant, so same idea now, but with sine. Cosecant's reciprocal is sine. So this is 1 over the sine of 4 pi over 3. So that is 1 over, find 4 pi over 3 on our unit circle. Right here, sine is, oh, hang on. Negative square root of 3 over 2. So this, of course, is negative 2 over the square root of 3. Rationalize this. That gives us negative 2 square root of 3 over 3. And one more. 1 over the tangent of 300. That's going to give us 1 over. Let's find tangent of 300. That's negative square root of 3. All right, so rationalizing this turns into negative square root of 3 over 3. All right, so there you go. Now on the next ones here, actually here, let's think about this. On questions 1 through 6, they give you angle measures. All right, so what I mean by that is they give you theta in this case, and we need to figure out, hey, if I punch this into my calculator, what value is it going to spit out? Whereas on these next ones here, they give you the answer and they want you to find the angle associated with it. So we're going to have 2 answers on each one of these because tangent, remember we talked about this pretty heavily in the last video. We have this all students take calculus thing. All right, so tangent is negative in 2 quadrants. It's negative in quadrant 2 and quadrant 4. All right, so we have to find the values associated with this. So there are going to be 2 answers on these things. So we're looking for negative square root of 3 over 3. And here it is. That goes with 150 degrees. Right? They're telling us, hey, put your answers in degrees here. So the first value, theta equals 150. Right? But there are 2 answers, and we know it's going to be in quadrant 4. So in your unit circle, go down to quadrant 4, look for that negative square root of 3 over 3. That's associated with the 330 degree angle. Right? If you're clever and you know your reference angles, that's a way that you can do this without having to flip back and forth. Both of these have 30-degree reference angles. You just need to figure out the quadrant that it's in. All right, so next one, sine of theta. Again, if we just write this one out, all students take calculus. I think I use sine as blue. Again, negative square root of 3. So we know negative sine values pop up in quadrant 3 and quadrant 4. So we have to find both values that go with that one, right? So in quadrant 3, we have negative square root of 3 over 2 goes with 240 and 300 in quadrant 4. So we're 240 and 300. All right, then the last one, the cosecant. And again, cosecant of theta, this one has an extra layer because this is 1 over the sine. 1 over the sine of theta equals negative 1 over 1. So to kind of get around that, take both of these fractions, flip them upside down. Now, fortunately, negative 1 over 1 flipped upside down stays negative 1 over 1, which is negative 1. All right, but again, it is a negative value, so we know that sine, all students, that should be a t. We need to find negative 1 here on our unit circle. I believe there's only one spot where sine is negative 1, which is right here, 270. So in this one, theta equals 270. All right, and there we have it. Using unit circle. So now questions 10 through 12, same exact thing, except they want our answers in radians. All right, so don't overcomplicate it. Just grab the radians this time. Cosine, it's positive. So we know cosine is positive. I'm not going to rewrite it every time. Cosine is positive in these 2 quadrants. All right, so look in quadrants 1 and 4 here. So where is cosine 1/2? It's 60 degrees and 300 degrees, but not degrees. They want radians. So pi over 3 and 5 pi over 3 are going to be your answers here. Theta is pi over 3, and theta is 5 pi over 3. All right, next one. Secant, this is 1 over the cosine equals -2 square root of 3 over 3. So flipping that upside down, we're going to have cosine theta. Where my theta here? Equals, I'm going to keep the negative on top, -3 over 2 radical 3, rationalizing that denominator. I'm going to put a root 3 on top, root 3 on bottom. That gives us, I'm going to do this all one go here, negative square root of 3 over 2, right? So cosine negative square root of 3 or 2, negative, so that has to be in quadrants 2 and 3. Right? So here's your negative square root of 3 over 2. That is at 7 pi over 6 and 5 pi over 6. All right, so theta equals 5 pi over 6. And theta equals 7 pi over 6. Right? Now, if you don't have this thing memorized, the unit circle, it does tell you your positives and your negatives, but it's a shortcut. It tells us exactly where to look. All right. Now this next one, cotangent is undefined. The cotangent can be simplified as the cosine of theta over the sine of theta. All right, that is one of our ratio identities that we have here. In order for something to be undefined, we need to have a 0 in the denominator. All right, so we need to figure out where is sine equal to 0 on the unit circle. So this is kind of what we're looking for. Where is sine equal to 0? Sine is equal to 0 on 0 and on pi. Right, so the two answers here, theta equals 0 and theta equals pi. Right, and again, we are looking for where sine equals 0, because when we have a 0 in the denominator, that's when we get that undefined. You type that into your calculator, it's going to say error, right? 1 divided by 0, it gives you that error divided by 0. That is your calculator's way of saying undefined. All right. So next one, unit circle. Answer should be between 0 and 360 degrees. All right, so what I want you guys to do, the very first thing, if you need to pause your video now, make sure your calculator is in degree mode. All right, if you are in radians, it's going to spit out the wrong answers here. So make sure you're in degrees. Right, and they want us to find this value here. So the first thing we need to do is we need to take the inverse. All right, so we talked about this, I believe, in the previous video. So the inverse cosine of 0.57357. Right, what does that give us? No clue. No one knows what that is. You're going to need your calculator for this. And if you have a graphing calculator, it's going to look exactly like my screen. If you have one of your own calculators, you're on your own. But it should look like this. That spits out 55. I'm going to call that 55 degrees. All right, so we have a 55-degree angle right here. So keep in mind, this is a positive number. We know cosine is positive in quadrant 1 and quadrant 4. So we need to have another one down in here. So we have to use that 55. That is our reference angle here of 55 degrees. But again, they want all of our answers between 0 and 360. So our second answer is really going to be this blue part right here, that coterminal angle. And to figure that one out, you need to do 360 minus that reference angle, minus 55. right? So that gives us 305. Right? So the two answers here, the first one ends up being that reference angle. So theta equals 55, right? And also theta equals 305. Right? So we're looking for two answers on these. The next one is the cosecant, right? So on this one, this is 1 over sine of theta equals this fraction, negative, or this decimal, sorry, 6.39245. Right? But we don't have the cosecant on our calculator, so here's what we do. We flip it upside down, and you're going to say the sine of theta equals 1 over negative 6.39245. And then the last step is the first step on the previous problem. We inverse it, right? So the inverse sine of this fraction is equal to 1 over, that fraction. Thank you. Negative 6.39245 equals theta. All right, so that's what we're going to type into our calculator. Again, make sure you have that inverse in there. 1 divided by negative 6.39245. And that gives you negative 9 degrees. Actually, I don't want to put a theta there. This equals negative 9. All right. Negative 9 looks like this. Right, that is our reference angle. All right, it's going 9 degrees clockwise. And actually, I don't even want to put that negative there. I'm just going to put a 9. Right, we know that this is a negative number. So we have to think, where is sine negative? Right, so sine is negative in quadrants 2 and quadrant 3 and quadrant 4. So our answers should be down here. But again, we don't want those 9s. Those 9s are the reference angles. So we are really looking for this answer right here, which is 180, right, half of a turn plus 9. So that's 189. And then the second one is going to be this guy right here, which is 9 degrees short of 360. So subtract it. So 360 minus 9. All right, and that's going to give us 351. All right, so the two answers for theta is equal to 189, and the second one is 351. And there we have it. So that was the first page. I'm just going to do the second page. We're just going to keep on keeping on here. I don't want to make 2 videos. All right, same exact process on these, but we have to be more careful because now it is in radians, and anytime we have radians, we do get some nasty decimals. So that's just something to keep in mind. So swap your calculator over to radians. Right. So with mode, go over to radians. That should be the very first thing you do on any of these problems. Right, we want radians, same exact process. The inverse sine now of that decimal point. 0.90963. And again, it's going to be an ugly number. Right? You're not getting those nice degrees that we have here. It's 1.14. So let me just write all that down. The inverse sine 0.909 equals 1 point, I think it was 1.14. Let me double check that. All right. So keep in mind, when we're in radians, we do get the decimals. So over here, don't think of this as 180 degrees. Think of this as pi, right? Think of the vertical ones as pi over 2 and 3 pi over 2. All right, so I'm just going to do 3.14 divided by 2, and that is going to be this number here, 1.57. right? And then the bottom one, if I wanted it, we're not going to need it on this one, is 3 pi. 3 times 3.14 divided by 2, and that's going to give us 4.71. Right? And then this one up here is, this is 2 pi or 0, so I'm just going to call it 6.28. Right? This kind of helps us figure out where that 1.14 should go. It ends up being in quadrant 1, like this. Right? If it was bigger than 157, it would be in quadrant 2. Right? Now, this is the reference angle, but it's also going to be one of our answers because sine is positive in Q1. We know sine is positive in quadrant 1 and in quadrant 2. Right? So we have to figure out this value right here. Right? So to figure that out, we're going to end up with 3.14 minus 1.14, and that gives us just 2. Right? So theta here is equal to 1.14, and theta equals 2. Right, so basically, if I were to throw that in my calculator now, since we have radians, if I throw in the sine of 2, keep in mind I did round. So this 90929, right? We have 90963. So it's really close. That rounding that we did does, come into consideration, but the sine of 1.14 should get us really close to that decimal as well. All right, so 90963, we're at 9086. All right, so it's a little bit farther off, but it's accurate to the nearest thousandth. All right, so that rounding, it does do things. So that's just something to keep in mind. All right, but the inverse tangent now of this one, 0. We got 2.2824. All right, where is that going to land us? The decimal there. All right. And then that 2 looks bad. All right. So we have the inverse tangent of 0.222824. Is that 0.219? 219, we call it 0.22. They want us to round to the hundredth, so that's what I'm doing. 0.22 is over here. Right, so here is your 0.22. All right, and it's a tangent. We know tangent is positive in quadrant 1 and quadrant 3. So this is also 0.22 here. And so we have 3.14 plus 0.22 because it's going past pi. All right, so this is going to be 3.36. And then the other one is at 0.22. So our two answers here, theta equals that reference angle that we got and that second answer that we found, which was 3.36. And on to the next one. So we actually did this in the previous video, but we did it in degrees. And anytime you do things in degrees versus radians are always, a little bit more difficult to kind of think about in our heads. So they want us to convert it to degrees. Anytime you want to convert anything to degrees, multiply it by 180 over pi, right? Those pi's are on top and on bottom now, so the pi's end up canceling. So you end up with 180 times 8, and then divide that by 15, right? So that is 96. This is a 96 degree angle, right? 96-degree angle, or an 8 pi over 15 radian, is in quadrant 2. That's just past the 90 degrees. So this is in quadrant 2. Should use a Roman numeral. Let's put a 2 there. Whatever, not a big deal. Name the reference angle. All right, so that is this one. So now you could think of it as you could get the degree first and turn it into a radian, or you could just think about, all right, we need to get to pi. So we have to just think, all right, 8 pi over 15 plus some number, some pi over 15, right? What number here gets us to 15 pi over 15? Right? Because 15 pi over 15 is 1 pi, right? So you just got to think, all right, 8 plus what gives us 15? And that's a 7. right? So the reference angle here is 7 pi over 15, right? That gets us back to the x-axis, or that is, gets us down to the x-axis. A larger coterminal angle, you need to add 360 degrees, or since we're talking about radians now, you need to add 2 pi. So 8 pi over 15 plus 2 pi over 15. Well, 2 pi over 1, or we can do this, 2 pi over 1 is equal to 30 pi over 15, right? We need a common denominator at some point, so I'm just going to do 30 pi over 15. All right, so that gets us 38 pi over 15. So that is a larger coterminal angle. 38 pi over 15. If we want a smaller coterminal angle, subtract the two. All right, if we were to subtract them, 8 pi minus 30 pi over 15, that is going to give us negative 22 pi over 15. So there's your smaller coterminal angle. All right. The complement, what is going to get us to 90 degrees, or what is going to get us to pi over 2? This one, I'm going to need another more room for it. We need 8 pi over 15 plus some fraction needs to get us to pi over 2. All right, pi over 2 is that 90 degrees here. If I, let's see here, that's going to be 7.5 pi. That gets kind of ugly. Here's what I'm going to do. I'm going to make everything over 30. So I'm going to multiply this by 2 over 2. I'm going to multiply this one by 2 over 2. That's going to give us 16 pi over 30 plus what is equal to, see, I messed up. I need a common denominator, so I need to multiply this one by 15 over 15. Gets us to 15 pi over 30. Right? And the answer for that is negative 1. Negative 1 pi over 30. Right? That is our complement. If we think about that, 15 pi over 30 simplifies down to pi over 2. Pi over 2 is equal to 90 degrees. A complement are two angles that when you add them together get you a 90-degree angle. So that negative 1 pi over 30 is the answer here. Negative pi over 30. Right? And the supplement, all right, what is going to get you to 180 degrees? All right, we actually already did that one. It's the one in purple, right? This gets us to 1 pi. All right, so that is also our supplement. All right, so 7 pi over 15 gets us to 180 degrees, or it gets us to 1 pi. Right, 8 pi over 15 plus 7 pi over 15 is 15 over 15 pi, which simplifies down to 1 pi, which is 180 degrees. So that's kind of your definition of supplementary there. All right, we got one more here, arc lengths and areas of sectors. So this arc length formula here, this is in radians, and I actually don't like the way that this is written, because if you notice, look at those 2 pi's. The 2 pi's end up canceling. So we could really say that the arc length here, where do I want to write this? I'm going to put arc length. Is just equal to CA, that stands for the central angle, times the radius. All right, so the exact arc length here is just, let me extend this down. The central angle here is 11 pi over 12 times 6. So this right here, this is your central angle. A lot of times we use a theta for that, and the 6 is your radius, right? Just multiply those two together. So if you want to multiply those, 11 times 6, you're going to have 66 over 12, 66 pi over 12, which of course does reduce down. If you wanted to, that just ends up being, you can divide them both by 6. So it's going to give you 11 pi over 2. Right, that is the exact value here, 11 pi over 2. All right. What is that? Is rounded? They want, what do they want us to round to? Doesn't say. Let's just throw in the calculator. 11 pi over 2 is about 12, 17.28, we'll say. Right. And then the area of the sector. So if we look at this formula now, the area of the sector, notice how the pi's cancel out. So the area of the sector, I'm going to abbreviate that. I'm going to say A, like for area, with a little s for sector. That equals 1/2. What do they have here? That is the central angle. I'm going to write it a little differently. I'm going to say 1/2 times the central angle times the radius squared. All right, that is the same thing here is 1/2 times the central angle, same thing as central angle over 2. All right, so plugging everything in here, you got 1/2 times 11 pi over 2 over 12, sorry, times 6 squared. That's going to give us, we have 11 pi over 24 times 36. I don't have a clue what that is. So here's what I'm going to do. I'm going to ignore the pi for now. 11 times 36 divided by 24. All right. That's 16.5. I don't know what that is, so I'm going to turn that into a fraction. That's 33 halves. Now I'm going to put pi back in. 33 pi over 2. Right? If you throw the pi in there, it will not turn it into that fraction for you. So leave the pi off until the end. Think of it, almost as a variable if you want to, because pi is an irrational number, so you cannot turn pi, that decimal, into a fraction. So the exact answer we saw is 33 pi over 2. All right. Now, if you want the rounded answer, take that 33 halves and multiply it by your pi. And now it'll give you that decimal, which is 51.84. All right. So there we have it. That is, what are we on here? That was unit 3. All right. So 3 down, 4 to go. We'll see you guys in the next video.